Good evening. This is James Lovejoy. I am the Department of Energy, Idaho Operations Office, National Environmental Policy Act, or NEPA Document Manager for the Versatile Test Reactor Environmental Impact Statement. Throughout the rest of this presentation, I will refer to the VTR Versatile Test Reactor as the VTR and the Environmental Impact Statement as the EIS. This presentation provides basic information on the NEPA requirements and the purpose of this public hearing, as well as a summary of information contained in the Draft VTR EIS. NEPA requires an agency to hold a public hearing after publishing a draft EIS. In this case, the DOE Office of Nuclear Energy is holding 2 virtual public hearings on consecutive days at different times to provide individuals who would like to participate the opportunity to do so. The purpose of the virtual hearing is for DOE to present information about the draft EIS and allow the public to provide oral comments. Public input on the draft EIS will assist DOE in evaluating the potential environmental impacts and facilitate a more informed record of decision. As mentioned during the introductions, following this presentation, those who so desire will have an opportunity to provide oral comments. For those who want to make comments but do not wish to speak tonight, information on other means of submitting comments and the deadline for doing so will be provided as well. DOE's Notice of Intent to prepare the VTR EIS was published in the Federal Register in August 2019. That was the start of a scoping period during which was held 2 virtual scoping meetings. DOE announced the availability of the draft VTR EIS in the Federal Register through press releases and by emails on December 21st, 2020. The Environmental Protection Agency Notice of Availability for the draft VTR EIS was published on December 31st, 2020. The opportunity for the public to provide comments on the draft VTR EIS continues through February 16th, 2021. DOE expects to publish the final VTR EIS during the spring of 2021, and a record of decision is expected during the summer of 2021. The draft VTR EIS is made up of 3 volumes. The summary presents a high-level description of the reason DOE is pursuing the VTR, the alternatives and options evaluated, and summary of the potential environmental impacts. Volume 1 includes the introduction, purpose, and need for DOE action, description of alternatives and options, information on the potentially affected environment, and potential environmental consequences of the alternatives and options. Volume 2 includes a summary of the comments DOE received during the scoping period I mentioned previously, and technical appendices that contain more detailed information or analysis that are provided in the main volume. The central feature of the VTR project is a new reactor in which test articles would be exposed to high-energy neutrons. The post-irradiation examination of these test articles would be performed in existing facilities or newly constructed facilities, or a combination of both. Because the project involves the operation of a test reactor, it also includes a management of the resulting spent nuclear fuel. Therefore, the project includes modification of an existing facility or construction of a new facility for treating and packaging spent fuel, and also provides a pad to store the disposal-ready canisters of spent fuel until they are shipped to an off-site storage or disposal location. The EIS evaluates potential impacts of 2 action alternatives: the Idaho National Laboratory, or INL, Versatile Test Reactor Alternative, and the Oak Ridge National Laboratory, or ORNL, Versatile Test Reactor Alternative. Under the INL VTR alternative, existing facilities would be modified as necessary to support post-irradiation examination of test articles and treatment and packaging of spent fuel to support the new reactor. This is DOE's preferred alternative. Under the ORNL VTR alternative, in addition to a new reactor, DOE would construct a new hot cell facility to support post-irradiation examination and spent fuel treatment. The VTR EIS evaluates potential environmental impacts associated with the VTR project at 3 DOE sites. As indicated in the previous slide, 2 DOE sites are evaluated for building and operating the VTR reactor itself: the INL site and the Oak Ridge National Laboratory site. And as well will be discussed in the next slide, 2 DOE sites are evaluated for performing the activities necessary to produce the reactor driver fuel needed to power the reactor. The 2 locations are the Idaho National Laboratory site and the Savannah River site. As described in the EIS, Department of Energy is evaluating 2 options for each of the capabilities needed for reactor driver fuel production. Feedstock preparation could be located at the Idaho National Laboratory or the Savannah River site, and fuel fabrication could also be located at the Idaho National Laboratory or the Savannah River site. At this time, DOE has no preferred option for where reactor driver fuel production and capabilities will be established. The reactor driver fuel required to operate the reactor would be an alloy of uranium, plutonium, and zirconium that is not commercially available. Consequently, DOE will produce the fuel. Reactor driver fuel production may require feedstock preparation, which could involve processing feedstock materials to remove contaminants and/or converting feedstock material to a metal form so it can be used in the next step of fuel fabrication. Fuel fabrication includes alloying metals, casting fuel slugs, fuel pins, and creating fuel assemblies from fuel pins. Existing facilities would be modified as necessary to accommodate the glove boxes and equipment needed to perform feedstock preparation and fuel fabrication. DOE does have a preferred VTR alternative. The preferred alternative is to locate the VTR at the Idaho National Laboratory site. That preferred alternative includes constructing and operating the VTR at the proposed VTR complex adjacent to the Idaho National Laboratory's Materials and Fuels Complex, modifying existing facilities at the Materials and Fuels Complex to conduct post-irradiation examinations of test articles and treatment of spent fuel, and constructing spent fuel pad near the VTR in the proposed VTR complex. DOE does not have a preferred alternative or option for the reactor driver fuel production activities of feedstock preparation and fuel fabrication. Establishing these capabilities would involve modifications of existing facilities at either the Idaho National Laboratory or the Savannah River site. Again, as described in the EIS, feedstock preparation could be located at either the Idaho National Laboratory or the Savannah River site, and driver fuel fabrication could be located at either the Idaho National Laboratory or the Savannah River site. Consequently, it is possible that both feedstock preparation and driver fuel fabrication could be located at either the INL or the Savannah River site. There is a potential for both the VTR alternative and one or both of the reactor fuel production capabilities to be located at the INL site. The INL VTR alternative would be constructed at the proposed VTR complex adjacent to the Materials and Fuels Complex at the Idaho National Laboratory site. Construction would disrupt about 100 acres, and completed project would occupy about 25 acres for operations. Existing Materials and Fuels Complex facilities would be used for post-irradiation examination of test articles and spent fuel treatment. Interim fuel storage would be provided at the facility at the VTR complex. The reactor driver fuel production options would include the modification and use of existing Materials and Fuels Complex facilities. The fuel conditioning facility is the proposed location of the feedstock preparation capabilities. The fuel manufacturing facility and zero power physics reactor building are the proposed locations for the fuel fabrication capabilities. These locations were selected primarily because of the existing and past experience with handling nuclear materials and infrastructure, which would allow the project to make use of existing facilities and capabilities, and thus contributing to a smaller potential for environmental consequences of siting the capabilities at these locations. Again, for the reactor driver fuel production capabilities of feedstock preparation and fuel fabrication, one, both, or neither could be located at the Idaho National Laboratory site. The Department of Energy has no preferred option for this at this time. Here is a regional view of the proposed locations of the VTR alternative. the reactor fuel production options adjacent to and in the Idaho National Laboratory site materials and fuels complex. The INL site was selected primarily because the project would make use of numerous facilities at the materials and fuels complex, along with a small potential for environmental consequences of siting the facilities adjacent to the developed location. The on-site location can be seen relative to the INL site boundary and regional locations of interest, including Idaho Falls, Craters of the Moon National Monument and Preserve, and the Fort Hall Indian Reservation. The solid blue blocks represent a conceptual layout of the new facilities to be constructed at the proposed VTR complex adjacent to and east of the materials and fuels complex. The green outline shows permanent operation areas of about 25 acres, and the dashed line shows an area that would be disturbed during construction, about 100 acres. Shown in orange are key materials and fuels complex facilities that would be used by the VTR project. These include the fuel conditioning facility, which is proposed location for reactor driver fuel feedstock preparation capabilities, and the fuel manufacturing facility and zero power physics reactor building, which are the proposed locations for fuel fabrication capabilities. Again, DOE's preferred VTR alternative is to locate it at the INL, Idaho National Laboratory site. However, DOE does not have a preferred option for the reactor driver fuel production capabilities at this point. Under the Oak Ridge National Laboratory, or the ORNL VTR alternative, the Versatile Test Reactor project would be constructed at a new proposed VTR complex about a mile east of the Oak Ridge National Laboratory main campus and a mile northeast of the Oak Ridge National Laboratory High Flux Isotope Reactor, or HIFER, facility. This would include a new hot cell facility that would be a joint post-irradiation examination and spent fuel treatment facility. A new fuel pad would be constructed as part of the VTR project to store treated fuel pending shipment to an off-site repository. This is a regional view of the proposed location of the Oak Ridge National Laboratory VTR alternative on DOE's Oak Ridge Reservation. This slide provides a view of the proposed VTR complex with respect to the Oak Ridge Reservation boundary and regional locations of interest, including Oak Ridge National Laboratory and cities and towns. As a reminder, Oak Ridge National Laboratory is not the preferred alternative for the location of the VTR and is not an option for fabricating the reactor driver fuel. The solid blue blocks represent a conceptual layout of the new facilities to be constructed at the proposed VTR complex. The green outline shows the permanent operations of the area of about 50 acres, and the dash outline shows the area that would be disturbed by construction, which is about 150 acres. The Oak Ridge National Laboratory VTR alternative facilities would be sited at the proposed VTR complex, which is a location previously considered for other projects but not selected. All new facilities would be constructed at this location. Under the Savannah River site reactor driver fuel production options, the feedstock preparation capability or fuel fabrication capability, or both, would be located at the K area complex. Core processes would be located in either the K reactor building or adjacent buildings. New glove boxes and equipment would be installed to perform feedstock preparation, fuel fabrication, or both. Alternatively, the capabilities and equipment required for reactor driver fuel production could be located at a similar L area complex. Reactor buildings in K and L area are the same design. This is a regional view of the proposed location of the reactor driver fuel production options at the Savannah River site K area complex. This shows K area complex with respect to the Savannah River site boundary, the L area complex, and regional cities and towns. Again, as a reminder, Savannah River is not a proposed site for the Versatile Test Reactor. It is only being considered as a potential site for reactor driver fuel production options. The K reactor building and K area complex pictured here is the proposed location of the reactor driver fuel production capabilities evaluated in the VTR EIS. These capabilities could include feedstock preparation or driver fuel fabrication, or both. Feedstock preparation and or driver fuel fabrication capabilities alternatively, could be located in the L area complex, which is about 2.5 miles east of the K area complex. The L area reactor building and L area complex is the same design as the K area reactor building. Similar to the INL site, these locations were selected primarily because of existing and past experience and infrastructure, which would allow the project to make use of existing facilities with small potential for environmental consequences of siting the capabilities at these previously developed locations. I'm going to close with a high-level summary of the environmental consequences of the proposed actions. The main difference between the Idaho National Laboratory and the Oak Ridge National Laboratory versatile test reactor alternatives. Number one, the Idaho National Laboratory alternative would make use of numerous existing facilities at the Materials and Fuels Complex and therefore disturb less land. In addition, the off-site population is further away and less dense at the INL site. However, both alternatives have similar no to low potential environmental consequences across all resource areas. The existing site's infrastructure support the construction and operation of the VTR. All waste that would be generated would be managed within the capabilities and capacities of newly constructed, modified, and/or existing on- and off-site processes and facilities. Health risks would be low, with no calculated latent cancer fatalities, or LCFs, to members of the public or workers, and one calculated traffic-related fatality over the 60-year duration of the project. Facility accident risks would be very low. At either the Idaho National Laboratory site or the Savannah River site, the reactor driver fuel production capabilities would largely be installed in existing facilities. Regardless of the site, there would be no to low potential environmental consequences across all of the resource areas. The existing site's infrastructures would support the construction and operation of the facilities. All waste would be managed within the capabilities and capacities of existing on- and off-site processes and facilities. Health risks would be low, with no calculated latent cancer fatalities, or LCFs, to members of the public or workers, and there would be up to 3 calculated traffic-related fatalities over the 60-year duration of the project. Facility accident risks would be very low. And the final slide provides information on how to comment and the end of the comment period. Thank you for participating in this important NEPA public involvement opportunity for the Versatile Test Reactor Environmental Impact Statement.